Have you ever thought about changing your eye color, thought about wanting to be taller, or thought about trying to fix a genetic disorder? With CRISPR-Cas9, this could be possible. CRISPR stands for Clustered Regulatory Interspace Short Palindromic Repeats. This is a technology that allows geneticists to manipulate the genome, or the genetic code, of organisms in order to treat genetic disorders and diseases that have a genetic component. This is done by adding a gene that was gone, deleting a duplicated gene, or by replacing a mutated gene with a healthy one. CRISPR is revolutionizing gene editing and how it's used to treat genetic disorders, as well as how much more cost-effective the technology is compared to gene editing methods that we have now. So first I'll go over how CRISPR works and the possible applications of the technology. So the CRISPR system utilizes the Cas9 protein, which can be programmed to target a certain sequence of DNA and is based off how bacteria defend themselves from viral infections. Jennifer Doudna, a geneticist who helped to invent CRISPR, in October of 2015 during her TED Talk said, "The reason we envisioned using the CRISPR system for genome engineering is because cells have the ability to detect broken DNA and repair it. The CRISPR system is not meant to fix the DNA, but rather to cut it and then let the cell repair the DNA naturally." So Cas9 uses guide RNA to make a double-stranded cut in the DNA that is complementary or has the correct pairing of nucleic acids to the guide RNA sequence. The Cas9 protein then introduces a new gene so that the cells can repair the DNA strand or just let the cell paste two strands of DNA together after cutting out the target DNA sequence. So this allows for defective genes to be cut out and replaced with a healthy, functioning version of the gene, which can be used to treat a number of genetic disorders or diseases that have a genetic component such as cancer. The CRISPR system has the potential to treat a wide variety of diseases that have a link to genetics such as cancer and cystic fibrosis. As of right now, the CRISPR system is mostly used to edit somatic cells, non-reproductive cells, since it is currently illegal to genetically alter germline cells or reproductive cells in most countries. It has been used in a very select few or life-threatening cases to save somebody's life or to treat human diseases. CRISPR technology is heavily regulated in what it can and can't edit, which can make research difficult when trying to find out all of the possible applications of the technology. With all the possible uses, one must also consider the cost us to use the technology, as well as the availability of the technology for the people who would need it. When compared to other forms of gene editing technology, CRISPR is far superior in terms of cost and efficiency. Some gene editing tools that we currently use include radiation and chemicals to induce the mutations in the genome. These are unreliable and can have severely detrimental side effects. The fact that CRISPR is so precise in where it makes its changes to the genome and how it makes those changes to the DNA makes it such a revolutionizing tool in the world of genetic engineering. According to the public engagement team of the Wellcome Genome Campus in an article titled "What is CRISPR-Cas9?", which was published on December 19th of 2016 on yourgenome.org, the CRISPR system currently stands out as the fastest, cheapest, and most reliable system for gene editing. This means that CRISPR is going to be more widely available to a wider variety of people, not just the richer upper class. This also means that the technology will be in a higher demand than other genome editing tools due to its reliability and preciseness. So now I'll go over a little bit of the future of the CRISPR system. So the future of the CRISPR is very promising and is on track to become a routine treatment for genetic diseases in humans, revolutionizing the treatment by eliminating the disease, not just by treating the symptoms of the disease. The CRISPR system is also likely to continue to raise more ethical questions, which, when experimentation on germline cells begin, especially with the ideas of creating a designer baby, where you can pick and choose physical characteristics of a baby, such as the eye color and the hair color. There's also talk of bettering the precision of where the cuts in the DNA are made to help eliminate possible errors. CRISPR has a wide range of possibilities and a very promising future for advancement. Finally, I'll do a little recap of what I've gone over. So the CRISPR-Cas9 system is an advancing way to treat and cure genetic disorders. The technology will continue to change and improve to better alter the DNA and to eventually allow us to alter the DNA of human embryos without the use of stem cells. The world of gene editing is and will continue being revolutionized by the CRISPR system when treating genetic diseases and making the technology more widely available, with the technology becoming even more cost effective and reliable.